Good morning, class. In our lesson today, we're going to look at a major application associated with complex numbers. And this is the AC circuit. And in this class, I'm going to focus on the series circuit with a resistor, inductor, and or capacitor. And what I want to do is first review with you three really important formulas that we're going to need. So here we have a formula for total impedance in such a circuit. And it is equal to the vector sum of the resistance, the inductive reactance, and the capacitive reactance. So when I say vector sum, we must picture the resistance oriented on the positive real axis, the inductive reactance on the positive imaginary axis, and the capacitive reactance on the negative imaginary axis. So we use this formula and we can compute the total impedance in both rectangular form, and then we can change that into polar form as well. And that's what the exercises will focus on today. If we're not given all three of these quantities in ohms, and instead we're given the inductance in henries or the capacitance in farads, then we would begin by using these formulas. So here we have a formula for inductive reactance, here one for capacitive reactance. Of course, to use the formulas, you do need to know the frequency. Okay, so I'm going to go through these 5 examples here with you. And here we're really taking a mathematical approach to this topic. I'm saving all the discussion of theory for your program teachers. Okay, so here is the instruction. We're going to determine the total impedance for each circuit. And we're going to round our final answers to 3 significant digits. But if we have to make some calculations first, before that final answer, we're going to keep 3 decimal places on those quantities. Okay, let's get started with this first one. The circuit in number 1 is an RC circuit, so there will not be an inductor, just a resistor and a capacitor connected in series with that AC source. And we have these values, 2 kilo ohms for R and 3.25 kilo ohms for XC. So I'm going to do that problem with you now, okay? So here we go. This is problem 1. And what do we have? We have the resistance is 2 kilo ohms. And the capacitive reactance is 3.25 kilo ohms. Now the formula for Z is right here, but since we do not have an inductor, we won't have this middle term. So we're just going to use R minus XC times J. Just like that. Now it's important to note that both quantities provided are in kilo ohms. So a nice way to handle this is just to use here 2 minus 3.25 J, and then off to the side I can just include the units kilo ohms for the whole complex number. Okay, the other thing I would like to do is write this now in polar form. So we're going to use our calculators. First thing to do is make sure you see a little D on your calculator display for degrees. And now we want to work in complex mode. So with your mode button, So press it once. Complex is mode 2. So press 2. And now you can see it actually indicates here that you're in the correct mode. And all you have to do is put this number into the calculator, but remember we use an I on the calculator, and it is here above the E and G button. So like this, 2 minus 3.25 I. Okay, just like that. Now we're trying to convert to polar form, so that is up here above the plus sign. So we do shift plus and then equals. And here's our number, and we're gonna round to 3 significant digits. So that's 3.82. Right here is where we would then put in kilo ohms. And then you're gonna make your angle symbol. And to get the angle to display, you just have to do shift equals. So shift equals, see the little angle symbol in the corner? So it's negative 58.4 degrees if we round to 3 significant digits. Okay, and that's all there is to it. So we're gonna try our next example. Now in problem 2, we do have all 3 circuit elements. Look, all quantities are provided in ohms. Okay, well these two are kilo ohms, okay? But overall, the unit is ohms. So I'm gonna just start with this first formula. So I'm gonna write down the values and we'll get started. So in problem 2, we have R is 425 ohms, XL 2.15 kilo ohms, and XC is 1.75 kilo ohms. We use the full form of the formula because we do have all 3 components. So this then becomes 425 plus 2.15 kilo times J minus 1.75 kilo times J. All right, so because only these 2 quantities have the prefix kilo, I couldn't treat the number in this way. I had to just keep the kilo where it was appropriate. Okay, so now before we convert to polar form, we have to ensure that we have just one imaginary part. So the real part stays 425, and to figure out the imaginary part, we actually need to take the sum of these 2 numbers. So take positive 2.15 kilo and subtract 1.75 kilo from it. And if you need it, you can use your calculator, okay? So let's just do that. 2.15 kilo minus 1.75 kilo is the number 400. Okay, now I don't have engineering mode on. If I did have engineering mode on, it would be 0.4 kilo instead. So that's up to you whether you keep engineering mode on as well. I think I'll just use this number. So I'm gonna have, and it's positive, so we're gonna have positive 400J. Okay? And this was the same as taking 2,150 and subtracting 1,750 from it. And now we're all set. We've got our total impedance in rectangular form. This, of course, is in ohms. And now if we want to write out the equivalent in polar form, we type it in. So 425 plus 400 I, so type it in, and then shift plus equals. This number we would round to 3 significant digits, so 584. Here's where I put the unit, which is ohms. Then would be the angle symbol. And to get the angle, it's just shift equals, like that. So here's the angle symbol. It's a positive angle. 43.3 degrees would be correct to 3 significant digits. Okay, so I think you get the idea. We will continue to complete this page of problems together. So let's look at number 3. Number 3 has all 3 components. Also, all quantities are in ohms. We have 400, 500, and 700 ohms respectively. So let's go ahead and calculate the impedance for that circuit. So 400, 500, and 700 ohms. Oops, I was starting to put an R here, sorry, instead of a Z. There we go, Z. And then we're using R plus XLJ minus XCJ. So R plus 500J minus 700J. So the next step is to collect like terms. Just as we did back here, we had these 2 imaginary numbers that we collected together. Overall, we had a positive imaginary number. In this case, if you take a positive 500 and subtract 700 from it, you will get negative 200. So we now have this complex number, 400 minus 200J. Now, before, when we had a positive imaginary part, we ended up with a positive angle. Let's convert this now to polar form. Okay, so 400 minus 200 I, shift plus, equals. Write that down, rounded to 3 significant digits, 447. Unit, ohms. What is the angle? Now I have a negative imaginary part, so I'm expecting a quadrant 4 angle. So all you have to do is shift equals, and you see that indeed we have a negative angle, and it would be in quadrant 4, negative 26.6 degrees. Okay, so when you have a positive imaginary part here, you'll end up with a quadrant 1 angle. When you have a negative imaginary part, you will end up with a quadrant 4 angle. All right, next problem. All right, so take a look at problem 4. Now we have an RL circuit. So this means no capacitor, just the resistor and the inductor. The quantities are given 20 kilohertz for the frequency, a resistance of 1.8 kilo ohms, and an inductance of 10 millihenries. Okay, so the key is that in this problem, we are given inductance itself, not the inductive reactance. So this means we will use that inductance along with that frequency to first get our inductive reactance in ohms. Okay, so let's go through that together. So we'll take note of all of the given quantities. Okay, and yes, the first thing we have to do is calculate XL. The formula for XL is 2 times pi times F times L. Okay? In this case, the frequency is 20 kilo. And the inductance is 10 milli. So we begin by performing this calculation. Now, I'm going to heed this instruction. I'm going to keep 3 decimal places on this calculation because this is not a final answer. Okay, so I'm going to punch this in the calculator. You make sure you use your pi button, not some approximation here, okay? You have a pi button. So we're going to do this. We're going to do 2 times, so the pi is here, so you have to hit shift and then hit that button. 2 times pi times the frequency, which is 20K, times the inductance, which was 10 milli. 10 milli. There it is. Okay, so look at what it looks like. Push equals. There we go. Now, again, I'm not in engineering mode, but I can just hit the engineering button. Oh no, I can't when I'm in complex mode. Oh, that's interesting. See, even I got fooled. Okay. Maybe let's put engineering mode on. You probably want it on anyway. Most students, I think, like to keep it on. So if I want it on, I have to go mode till I get display. And then I'm going to put engineering mode on. Okay, so now I've got everything. Complex mode, I'm in degrees, and engineering mode. And I'll just do that calculation once more, okay? 2 times pi times 20 kilo times 10 milli. All right, so this is probably what most of you would have is engineering mode on. So you get the prefix kilo here, and we're gonna keep the 3 decimal places. So I'm gonna write 1.257 kilo ohms. 1.257 kilo ohms is correct for that inductive reactance. Okay, now we have an RL circuit, so it means we'll only be using this portion of the formula. Okay, so from the original, we don't have the last term, just the real number and the positive imaginary number like this. Okay, so now the resistance is 1.8 kilo ohms and the inductive reactance is 1.257 kilo ohms. So since they're both kilo ohms, I'm gonna just put that off to the side and here use 1.8 and 1.257 respectively. Okay, and that's, again, they were both kilo ohms, so it makes sense to do it this way. If I do it this way, you see I don't have to put that kilo in my calculator now when I do my conversion to polar form. So I just have to do 1.8 plus 1.257 I, and then go shift plus equals. Okay, so there it is. And this is a final answer. So I do want to round this to just 3 significant digits, and that actually will make it 2.20. Here's where I would make note that this is kilo ohms. Next, for the angle, we simply do shift equals. All right, and you can see it right there, 34.9 degrees. All right, and now I've solved the problem. So in a question like this, when you are given henries, you need to first use that inductance along with the frequency in this formula to obtain the quantity in ohms. Then you can go to your impedance formula. Okay, I think we have just one more to look at together. So let's look at the final problem. It's back to having all 3 components, but not only are we given the inductance in henries, we're also given the capacitance in farads. So we're going to begin the problem by using both the XL formula and the XC formula. Okay, so let's try that. Okay, so this is problem 5. We have 300 hertz, a resistance of 200 ohms, a 1 Henry inductor, and a 500 nanofarad capacitor. Okay, so let's begin with our calculations for both XL and XC. So 2 pi FL will be 2 pi times 300 times 1. Okay, so this is 600 pi. So 2 times pi times 300 times 1, if you like, is this number, okay? Kilo. We're going to keep 3 decimal places, so it'll be 1.885. 1.885 kilo ohms. Okay, on the XC value, we will also keep 3 decimal places. Now this formula is 1 over 2 pi FC. So in this case, it is 1 over 2 times pi times 300 times 500 nano. Okay, so with these 1 over formulas, I like to just punch in the whole denominator first and get a value for that. And then we can simply invert that quantity. So I'm just going to punch in the bottom like this. So 2 times pi times 300 times 500 nano. 500 nano equals. So this quantity with the prefix micro is the denominator, okay? And we want 1 divided by that answer, which can be accomplished just by using this button right here, x to the negative 1. So I do that now, x to the negative 1, and equals. And here is my answer. And I'm going to keep 3 decimal places, 1.061 kilo ohms. Okay, do you need to see that calculation one more time? Again, just punch in the bottom, 2 times pi times 300 times 500 nano equals, there we go. Make sure you push equals, then flip it with this button. X to the -1 equals. All right? Okay, now we're all set. We can go to our formula, which is R plus XLJ minus XCJ. And I did include kilo here and kilo here because the resistance is not in kilo. Okay, so we handle it like that. And then, as you know, the real part will not change here. All I have to do is collect these two numbers together. And you might want to do that with your calculator. So we want to take 1.885 kilo. And from that, subtract 1.061 kilo. And we get this, 824. So plus 824J, just like that. And now all I'm gonna do is convert that to polar form to complete the problem. So we do 200 plus 824I, shift plus equals. All right, and so here's our answer. 848 would be correct for the number of ohms. Okay, and as for the angle, shift equals gives us 76.4 degrees. Okay, and there you have it. So that's all I wanted to cover in this particular video. So you now have solutions to these 5 problems. So please go ahead and try some practice problems using these as your guide. Okay, thanks and have a great day.